Welcome to the Pixel Maths Walking Talking Mock. This is a statistics higher tier paper. This table gives information about the water resources and population of 7 countries in year 2000. We need to extract some particular information from this table. First, we need to write down the name of the country that had the biggest population. So let's take a look at population. Population is here, which is what we're looking for, and we're looking for the biggest out of these numbers shown here. These are all in millions. We're looking for the largest number, which is here, 43.3. So the name of the country is South Africa. Now we're asked to identify the country that had the largest amount of renewable freshwater resource per person. So now we're looking at a different column. We're looking about renewable freshwater resource per person. This is here shown in our first column here. So we're looking for the name of the country with the largest out of here. And we can see our largest value there is shown here that corresponds to Somalia. We're then asked to write down the names of 2 countries that could supply all of their shortfall in fresh water from wave-powered desalination. So here, now we are looking here at our column here. We have 2 values here. First, the cubic kilometres per year and the percentage shortfall. So we are looking at any percentage that is over 100. So we have here and here are 2 options, Antigua and Somalia again. So we're looking for the values that are greater than 100, Antigua and Somalia. Some students revise for a mathematics exam. They use an internet revision site. The scatter graph here shows the time 7 students spent on their internet revision site and the marks they got in their exam. We're asked to plot this information here for further 3 students. So first we have 7 hours on the site, so it's halfway here between the 6 and 7, and a mark of 50, so plotting a further coordinate. We then have 10 hours on the site and 56. Looking here at 50, we then go up 1 to 52, 54, 56 here. Then for 16 hours on the site, we're going up to 78. So that's up to 80, go down 1 square that represents there, 78 for the mark. We're now asked to describe and interpret. This is different to what you would do in your GCSE exam. We're asked to describe the correlation and interpret. So to describe it, it's positive. To interpret, we need to use the context here of the question. So we're looking here at the number of hours increases, the mark increases. So as one value is increasing, the other value is increasing. Now taking your ruler, you need to draw a line of best fit. This line needs to go approximately through the middle with a similar number of points above and below the line. So taking your ruler out, we're looking for a line approximately there through our points. We can see we've hit quite a few of the points. We've got a few points above, 1, 2, 3, and about 4 below the line. Now we're going to use this line to estimate the mathematics part if the student spent 11 hours. So taking your pencil and ruler again, you're going to go to 11 hours, halfway between 10 and 12. Go up to your line of best fit and then draw a line across. So for my line, my mark is coming out here at 64. So the estimate using my line would be 64. However, your line may be slightly different, and in this case, the examiner allows any answer between 62 and 67. Deanside Town Council wants to improve council help for the arts. The council wants to find out which aspects of the arts the adults would most like to support. They decide to ask a sample of the adults. So this means instead of asking all the adults who live in the town, they are only going to ask a group of adults, a sample. So 2 advantages of using a sample rather than a census. So one way to think about an example, if at your school they wanted to find out what the students thought about a particular issue, instead of asking every single student in the school, they may ask 2 students from each tutor group. That would be a sample. So you can see that using samples are cheaper, quicker, and easier. So when asked for 2 advantages, any of those 3 there. We're then asked to describe a suitable sampling frame that could be used. So this is a list from which the sample is created, and it must include all of the adults in the town. So this could be the electoral roll, the register that is used for voting, or alternatively, a list of council tax payers / residents. The important part is the list must include all members of the population from which the sample is created. We're told that the council sends a questionnaire to all the adults living in one district of the town and asks to discuss whether or not this would be a good sample. Now, if they just send the questionnaire to all the adults living in one district of the town, this is biased because it does not represent all the people of Deanside. It's not a good sample. We're then given 2 questions on the questionnaire, and it's asked to explain what is wrong with each question. Let's take a look at the first one. The money that council will be spending on the arts is a great moment in Deanside Council history, isn't it? So the problem with this question is that it's a leading question. It's a biased question because it's trying to persuade you to agree. So the problem with this question is it's a leading question. Or biased because it is forcing you to think and to say yes, that the money the council will be spending is good. Our second question says, how much extra would you be willing to pay on your council tax bill to support the arts? The problem here is that we have overlapping boxes. So if, for example, someone said £1, would they tick here or here? So first, the problem is we have overlapping response boxes. But secondly, and another problem, is they do not ask over which time period. So how much extra would you be willing to pay per week, per year, per month? So there is no time frame in the question. Here are the ages in years of 15 teachers. We're asked to draw an ordered stem and leaf to show this information. We must include a key. So let's take a look at the youngest teacher here, 23. So our first row will be for the 20s and our first value is 3. Our largest, our highest number here, the oldest teacher we have is 53. So on our rows down here we must go 30, 40s and 50s. So let's continue now with the 20s. We have 27 and 28. Moving on to the 30s, 31, 34, 35 and 36. No more 30s, now on to 40s. We have 41, 42, 44, 45 twice, so 2 5s here. Now our 3 remaining numbers, 50, 0, 52, 2, and lastly 53. Picking any number to make a key, for example 3/5, is 35. Before we move on, just check we have 15 numbers here, that we have 15 numbers in our stem and leaf diagram, just to check we haven't left any behind. Now we're asked to identify the medium age. The medium age is the number in the middle. So starting from here, crossing off our smallest and our biggest, our next smallest, our next biggest, our next smallest, our next biggest. We see crossed off the bottom 3 here and the top 3 here. The next smallest, the next biggest, smallest, biggest, smallest, biggest, smallest, biggest. We have one number in the middle here, which is 41. So the medium age is 41. We're then asked to find the mean age. To do that, we must take the total and divide by 15. Adding up all of those numbers, our total number of years is 586. Divided by 15, just 3 significant figures, is 39.1. We're then told that the school gains an extra teacher who is 41 years old, and asked how will this affect the median age. Well, if we had an additional value in here for 41, it would mean that we would have 2 numbers here in the middle. They are both the same numbers, so when you add them up and divide by 2, we still get 41. So in this case, the median will stay the same. However, when we look now at the mean, we had a total of 586. We must now add our new age of 41 and divide by 16 rather than 15. Doing that gives us a mean of 39.1875, so slightly larger. So here, what happens to the mean? It will increase. We're then told that a teacher is now picked out at random and asked what is the probability they are more than 44 years old. So taking your highlighter, let's identify how many of the teachers are more than 44. So that doesn't include 44, 45, 2, 3, 4, 5. So we have 5 out of the 15, 5 teachers out of 15, 16 if we are looking at our extra teacher who is 41. So instead of dividing by 15, we need to divide by 16, so we have 5 over 16. Samina recorded the times in minutes some girls took to do a jigsaw puzzle. Samina used her results to work out the information shown here in the table. On the grid, draw a box plot to show the information in the table. So we need to draw a box plot here, the smallest, and then a box here, where we have our lower quartile, Q1, then here, our medium, Q2, here, our upper quartile, Q3, and here, our largest value, so the longest time. Here we have Q1, Q2, and Q3. So taking your ruler now, first to make a mark at 18 for the shortest. So reading the scale here, we have 15 going across to 16, 17 and 18 here. Drawing a short line there. On the other side, for the longest time here, our highest value we have shown 44. So going across here and drawing a short line here to represent the longest value. Then for quartile 1, the lower quartile at 25, we draw a longer line. This is the first part of the box. Then moving on to the medium, the quartile 2, 29. And then the upper quartile, quartile 3 at 33. Shown here. Connecting these lines now to make a box. And then extending out towards the longest time and here the shortest time. We're then told that the box plot below shows information about the times and minutes some boys took to do the same jigsaw puzzle. And we're asked to compare the distribution of the girls' times with the boys' times shown here. So the first thing we'll be looking at is the average, the median. We can see here that the median is 20.5, whereas our median here is 29. So the first comment in terms of comparison is that the boys were quicker on average. And we can see that by comparing the two median values. We then need to look at the spread. And to do this, we need to calculate the interquartile range. So here for the girls, 33, the upper quartile, subtract 25, which gives us an interquartile range of 8. When looking here at the boys, we have our upper quartile here, which is 28, and our lower quartile shown here, which is 19. So 28 subtract 19 here gives our interquartile range of 9. Therefore, the boys' results are slightly more spread out than the girls. Here the interquartile range is 9 in comparison to 8. So secondly, the boys' results spread out slightly more than the girls. And we can see that by comparing the interquartile ranges. This question is related to a tree diagram. We're told that Tom and Sam each take a driving test. The probability that Sam will pass the driving test is 0.8. Therefore, the probability he will fail is 0.2. This must add up to 1. Similarly, the probability Sam passes is 0.6. Therefore, the probability he fails is 0.4. Again, there's no difference if Tom passes or fails as to what Sam does, so same again, 0.4. Now we're asked to work out the probability that both Sam, Tom and Sam pass their driving test. So taking a look at our tree diagram, if they are both going to pass, we will start here, we'll go along here to take a pass, and then along here to take another pass. So this is both of them passing. Multiplying through with our probabilities, 0.8 multiplied by 0.6, the two probabilities here and here, gives a total probability of 0.48. Now we're asked for a different situation, the probability that only one of them will pass the driving test. So if only one of them passes, there are two ways this can happen. First, Tom can pass. So if we go along here, Tom passes, and then Sam fails. Option number 1. Alternatively, we could have that Tom fails and Sam passes. Option number 2. So taking a look at the associated probabilities. First, for the yellow route, 0.8, 0.4. Write out your working out, your calculations. And here for the orange route, 0.2 multiplied by 0.6 gives us our probability of 0.12. Adding these together gives us our total probability of 0.44. The table shows the average prices of a one-bedroom flat bought in Deanside for a period of 5 years. It also shows some of the chain-based index numbers for the average prices. We're told that the prices are given to the nearest 1,000. So first, taking a look, we're asked to calculate to the nearest whole number the chain-based index numbers for the years 2011 and 2012. Two missing values here from the table. So starting off with 2011. We need to take the 2011 price, divide by the 2010 price, that's the previous year, times by 100. So here we have this year, and here we have the previous year. So we're looking at the 2011, 127, divided by the previous year, 123, times by 100 is 103. Looking now at 2012, we take our price for 2012, 131, divide by the previous year, 127, times by 100 is also 103. A different calculation, but same value there for the chain-based index number. For the years 2008 to 2012, all shown here, write down the largest annual percentage increase. So having a look here in prices, we can see going from here to here, we have a plus 25. From here to here, we are negative 4. Remember, this is in thousands, so we're 4,000. Here, we are going up by 4, and here again, we're increasing by 4. So the largest increase, the largest annual increase, is going to be here between 2008 and 2009. But we're asked to actually calculate the percentage increase. So to do that, we will take our value in 2009, 127, subtract the previous year, which is the 25 we've just calculated, divide here by the original amount, 102, and times by 100 to get the percentage increase of 25%. We're then asked to calculate the geometric mean of the chain-based index numbers for these 5 years and give our answer correct to 1 decimal place. To calculate the geometric mean, we take the number of years, in this case 5, and we do the root of all of our values multiplied together. So we have 123 times 125 times 97 times 103 times 103, which gives our value for the geometric mean of 109.6, correct to 1 decimal place. "11 dragonflies are observed. Their wing lengths are measured and the territories they occupied are ranked in descending order of size. The data is summarised in the table below. First, we need to use the table to rank the wing lengths in descending order. So our first rank number 1 is going to be the wing length with the highest value. So here we see our highest value as 15.3. So that's rank number 1. Then 15.1, then 15.3. 15.0 is the third rank. Going to 4, 5. I'm going down in order of size here. 6, 7, 8, 9, 10, and our smallest wing length in place number 11 is 13.6. Now we're asked to calculate Spearman's rank correlation coefficient for the territory against wing length. We're provided with 2 further values. For this, we must first find the difference and then square the difference. The difference we are looking at here is between this rank and this rank here. So here we have a difference of 1. From here to here, we add 1. Here, 2. 2. Here we go from 4 and down to 1. So minus 3. 3, 0, 0, minus 5, 1, minus 1, 0. Squaring each one of those differences, we have 1, 4, 4, 9, 9, 0, 0, 25, 1, 1, and 0. To be able to calculate Spearman's rank correlation coefficient, we are going to use our formula as shown here. 1 subtract 6 times the sum of d squared divided by n bracket n squared minus 1. So let's take a look at each one of these values. N is the number. We know our total here is 11. So n equals 11. Here we have 11 squared. This part, the sum of d squared, is here from finding our total here. So this is equal to the sum of d squared. Adding up all of those values, we have 54. So now substituting the right places, we have 1 subtract 6 times 54 divided by 11 bracket 121 minus 1. Calculating that further, putting this into brackets, working everything out separately, dividing, taking away from 1, we have 0.755. So check that when you put all those numbers into your calculator, simplify, finding out the final answer, you should get 0.755. We're then asked to comment on this answer. As this answer is positive and near 1, we can see here that we have a positive correlation. But what does that actually mean? Well, it means there's a relationship here, and that as territory increases or wingspan increases, territory increases. So territory increases, wingspan or length also increases. So they both increase together. Two students, Paul and Jane, did examinations in May in mathematics and in English. Both examinations were marked out of 100. Here we have the tables shown, together with the mean and standard deviations of the overall subject marks in each subject. We want to know who did the best. First, we're asked to explain why students' standardised scores could be used. Standardised scores are really good because they allow us to compare data from different distributions. So the important part here with a standardised score is that they can compare data from different distributions. So here we're going to be able to compare the data here from the mathematics with the data here from the English. So first we need to work out Paul and Jane's standardised scores in both subjects. First, let's take a look at Paul. And let's look at his maths. So for Paul's maths, we take his value, 55, subtract the mean, 60, divide by the standard deviation, 15. So Paul's maths score is negative 0.33. And his English, we take Paul's score for his English, 47, take away the mean, 45, divide by the standard deviation, and we have 0.25. Comparing that now to Jane. When we look at her maths, we take Jane's score, 65. Take away the mean, 60, divided by the standard deviation, and we have positive 0.33. For her English, Jane's score is 45, as is the mean, divided by the standard deviation here of 8, and we are looking at 0. We then need to comment on the examination performance of these two students. So there are a few things we can say. First, if we take a look at English, we can compare our English scores here. This is larger, it's more positive. Therefore, Paul did better in English. So our first comment can be related here to English. So Paul did better in English. When we look at the math scores, we can see that Paul's score is actually negative. So Jane did better in maths. And we can say the opposite way, that Paul did worse in maths and that Jane did worse in English. A further comment we can make about the two scores is that Jane did better overall because she didn't get any negative scores. So Jane did better overall as no negative scores. The table shows information about the time, minutes, it takes to show each of the 120 films. We're asked to identify the modal class interval. We must look at the frequency, look at the highest, and find the corresponding group. So our modal class is here, m less than or equal to 100, but greater than 90. Now to write down our cumulative frequency. We find this by using our frequency. Our first value is simply 4, as shown here. We then must take the 4 and add 12. 4 plus 12 is 16. 16 plus 34 is 50. Add 32 is 82. Add 26 is 108. And lastly, add 12 is 120. So make sure there, before you move on, that your final answer in here, the 120, corresponds to the number given in the question. If you've got 119, you'd know you've made a mistake. Now to the plotting. To plot our cumulative frequency graph, we must take these values, the upper part of the class, and plot against our cumulative frequency. When we plot, we expect to see an S-shaped curve like this, starting right here at the origin. So first we're going to plot 80 with 4. 80 with 4. 80 is here. Finding 4 is easy if we have a look across here, go halfway, and we can see this is 10. 5 spaces down here, so 2 is going to be 4. we're going to go 2, 4, 6, 8, 10. So our first coordinate is here at 18 and 4. Then we have 19 and 16. 150. 110, 82. 120, 108. And lastly, 130 with 120. Then taking your pencil, remember we're going to draw a smooth S-shaped curve. You need to make sure you go through all of the points shown here on your cumulative frequency graph. Through your points up to here. Now using our graph to find an estimate of the median. Well, we have altogether 120. So halfway dividing by 2 will be the 60th value. So looking here at 60. Taking our ruler, drawing a horizontal line across at 60, and then down to the x-axis here. In this case, gives a value here of 102.5. The examiner will accept any answer between 101 and 105. We're then asked to estimate how many films lasted longer than 115 minutes. So going to our x-axis and going across to 115 here. Taking our ruler again, drawing a horizontal line up, our vertical line up, and then a horizontal line across, we then can read off our value from our y-axis here. So here we have 80 going up here, going up, we're going to go to 90, which is here. 2 more up, each one box is worth 2, so here we have 94. But we're interested in the films that lasted more than, so we're interested in this part here. So 120, subtract 94, is going to leave us with 26. So really important that the subtraction takes place to be able to find here our number of films as an estimate as 26. Your number may change given on your graph and the number you find here. The important part is that it's 120. Take away your value to give your final estimate. The table shows the quarterly profits in pounds millions recorded at the end of each quarter in 3 years, 2001, 2002 and 2003. Here we're asked to use the table to work out the 4-point moving averages. The first few have been done for us. If we look here at the calculation, we can see our first one is by adding quarter 1, 2, 3 and 4 together, dividing by 4 to get the first 4-point moving average. So moving on from here, we are going to be adding 3.2, 2.6, 3 and 3.4 and dividing through by 4 to get our first 4-point moving average of 3.05. Our second moving average, we are going to be taking 2.6, 3.0, 3.4 and 3. Adding those up, dividing by 4 gives us our next 4-point moving average of 3.0. Then moving on to our last 4-point moving average, we will be taking now 3, 3.4, 3 and 2.6. Adding up those three values, dividing by 4, gives our moving average of 3 again. Using this information, we need to plot the moving averages here on the trend line. So we can see here, the time series graph has been drawn, and we're going to plot these values here on our graph. So first off, we're going to be halfway. We've got Q1 and Q4 halfway between our points. We're going to be here, and we're going to be plotting at 3.3. So looking here, 3.2, we're going 3.25, so 3.3 will be here, 1 square up. Then moving across between Q3 and 4 here, and we have 3.25. Then moving now to the next, we have 3.2. Then again 3.2. Then down to 3.15. Then 3.1. And then 3.05 there. Then down again to 3 here, and lastly again 3 here. Then we're asked to draw in a trend line. So using this, we're going to draw a line of best fit through our moving averages. So here we're going to be looking at approximately through there. We're then asked, are the profits going up or going down from January 2001, so here, until December to 2003? Well, as the trend line is going down, decreasing, we have profits going down. So the profits are going down, and we can see that because the trend line is downhill in this direction, down. We're then asked to find the equation of the trend line. So to do that, first we need to identify the y-intercept. So if we look here, we can see where our line is crossing, and here we will have 3.4. So our intercept will be equal to 3.4. So this is an equation we're looking for a straight line. So y equals mx plus c. So our c part will be 3.4. We then need to identify our gradient. So to do that, we're going to take a look here. And if we start here at the beginning, we go across, and we're looking at how many quarters we are going across. So we can see here, right to this point, we're making 2 points there where the line actually crosses. So here is a clear point here. Our trend line is directly at 3 here. And then here, our trend line is directly at 3.4. So to find the gradient, we're going to go across 10 quarters. So going across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 quarters, and we are going down 0.4. So in this direction, we're going across 10, and here we go down 0.4. So our gradient there is the difference in the y, which is negative 0.4, divided by the difference in the x, which is 10, which gives a gradient of negative 0.04. The important part here is you can just go across 5 or 1, but it's clearer to see by picking 3.4 here, going how far across, and then at the next point that actually crosses here at the line, our trend line going at 3. So we have our gradient, our m value here, and our c value. So putting that in an equation together, we have y equals negative 0.04x plus 3.4. We're then told that given the mean seasonal effect of the first quarter is plus 0.05 millions, estimate the profits at the end of the first quarter of 2004. So here we can see we are looking here at the difference. We need to extend our trend line. So extending our trend line there, we can then see this line and the difference here going into the first quarter of 2004. So here we will be looking at 2.9 added onto our 0.05 million, which gives us a total of 2.95 million. In this question, we're told that a company fills tubes with 4 different coloured sweets. Each tube is supposed to contain 6 reds, 6 oranges, 6 browns, and 6 greens. So altogether, there should be 24 sweets of those different green colours. We're told that the tube contains the correct number of sweets of each colour and a sweet is chosen randomly from it. Write down the probability the sweet is red. So how many reds? 6 out of the total 24, which we can simplify to 1 over 4. We're then asked to work out the probability the sweet is not red. To do the probability of it not being, we take away the probability that it is from 1. So here we have 3 over 4. The tubes do not always contain the correct number of each sweets. It is known that the probability that a tube of these sweets chosen at random contains 6 green sweets is 0.9. So the probability that it does contain is 0.9. Therefore, the notation used here, the probability it doesn't contain is 0.1. These two adding up to 1. We're told that Jacinda buys 4 of these tubes. So the 4 of these tubes is important. And here we are given a sequence to help us work out the probability. So we have our 4 here. We're asked to work out the probability that 3 or more of the tubes can contain exactly 3 sweets. So we need to look at this part, which represents 4, and this part that represents 3. We're then going to add that together to find the probability of 3 or more. This would represent 2, this would represent 1, and this would represent 0. We're not interested in those because we're looking at the probability of 3 or more. So first we're going to be looking at 0.9 to the power 4 plus 4 times 0.9 to the power 3 times 0.1. So working out this separately and then adding to the 0.9 to the power 4, we have the total probability as 0.9477. In an experiment, a psychologist records the time, X seconds, for 50 people to complete a puzzle. Results are shown here on the table. So here we have our total of 50 people. First, we're asked to identify an estimate for the mean, and using the space provided shown here in the table. Because we have grouped data, we need to find the midpoint of each group. So between 0 and 40, the midpoint is 20. Between 40 and 60, our midpoint is 50. 70, 90, and 140. Now we have our midpoint, we can take our frequency and times this by the midpoint. We then have our values shown here, 200, 450, 840, 810, 1,400. Adding up all the numbers in this column, our total comes to 3,700. We can now work out the mean. 3,700 divided by 50 equals 74. We're now asked to calculate the standard deviation. We're told we need to show that the standard deviation for the time is approximately 40 seconds. So we must calculate, and the answer we're expecting is approximately 40 seconds. So to find the standard deviation, we must square root the sum, the total of fx squared divided by the sum of f minus the mean squared. So first off, we already know the mean. Our mean here was calculated in part A. So we must take our 74 and square it. Now here to our first part, our x here is going to be our midpoint. So we must square our midpoints and then times by the frequency. So if we use our last column here to find the frequency times the midpoint squared. To do that, we then have the following values. 4,000, 22,500, and then the total 3,435 54200. Dividing through by 50 and subtracting our 74 squared. We then have the square root of 1,608. Square rooting that will give us an answer of 40.0999. Rounding, we have 40.1. So therefore, the standard deviation is approximately 40 seconds. We're then asked to draw this information on a histogram to represent what's shown here in our table. So to do that, we're going to need to calculate the frequency density. So taking another colour, we're going to calculate here for our histogram the FD, the frequency density, which is equal to the frequency divided by the class width. So having a look here, our class widths are 40, 20, 20, 20, and 80. Using that information, we are then going to calculate the FD. So taking our frequency and dividing by the class width. So our first frequency is 10 divided by 40. So our first frequency density is 0.25. Then we have 9 divided by 20, 0.45. 12 divided by 20, 0.6. 9 divided by 20 again, so 0.45. And lastly, our frequency 10 divided by 80, 0.125. Now we're not provided with a scale or axes drawn here, so we need to make sure that our graph fits onto the grid paper provided. So taking our ruler, starting here at the very edge of the graph, we need to ensure that our y-axis, our frequency density, goes as high as 0.6. So starting here, we have one big square there, up to 10, a second one here, and a third one here. So splitting that now, we go from here, counting up, 1, 2, 3, 10, counting up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our first point here, 10, counting again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here. And again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here. And again here if we were to continue. Now this does not go as high as 6, so each one we're going to need to halve to make here 0.2, 0.4, 0.6, and here 0.8. Leaving inside, here we have the frequency density. Now moving along here to our x-axis. So taking your ruler again and drawing a line across. Now let's take a look at our values here. We need to go from 0 to 180. If we split up into 5s, we have here 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. So going along here, again further along, sections going. So do we have enough to do 10 for each one? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150. We haven't got far enough, we haven't got the grid big enough to go 10 across, so we're going to have to half down. So doubling here, we're going to have 20, 40, 60, 80, 100, 120, 140, 160, 180. Now using this information and what we've already calculated for our frequency density, we can now start drawing our bars. So again, taking your ruler, And our first bar is going to be at 0.25. So 0.2 is here, 0.3 is here, halfway across here, and our bar goes from 0 to 40. So just there. Our second bar will go from 40 to 60, but this time it will be at 0.45. So we have our bar, our horizontal bar across at this point here. I'm going to draw in our vertical lines in a moment. We then have our next bar, which is 0.6. Again, only 20 across, so just across there. And we go back down from 80 to 100, which is 0.45 again. So a further line across here. And then lastly, we drop down from 100 to 180 to 0.1, so halfway up, to 5. So again, going up to here across. To 180. Then doing your vertical lines in between. Making sure you're always drawing your histogram with a ruler in case you need to make any changes. And the last bar to complete here. Okay, so now we have our completed histogram. We need to shade the region in your histogram that is within 2 standard deviations of the mean. So first off, let's draw our mean line in. So taking a different colour, drawing our mean line, we know our mean is 74. So going here to 70 and going across to 74. So approximately here. So this here is our mean line. At 74. 2 standard deviations, so we know our standard deviation is 40.1 times 2 gives us a value of 80.2. So here we now have our mean line at 74, and we can go below by 80.2 and above by 80.2. So that means that all of the area below the line, our mean line, will be shaded. So everything in here, in our first bar, second bar, third bar, partly through here, and then above, we are going to be taking our 74 and adding on here. So we're going to go up to 154.2. So taking a ruler again to identify that particular point, 140, 150.2 will give us a line here. Again, taking out your highlighter to shade the region, we're looking at the rest of this bar, all of this bar, and part way through the final bar. Okay, we're then asked to find the proportion of people represented by this region. So we've got in total 50 people, So we're going to try and work out of the 50, how many are in the shaded section. Well, the first 4 bars are completely shaded. So here, 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 and here. So we already have 40 people that are in this section. We then have here part of these 10 people. So we actually have, from this section onwards, 54.2 of the final section. So here we are going to be looking at 0.125, the frequency density here, and then from 100 to 154.2, so timesing here by 54.2, the difference between these 2 parts. Remember, we're going to add that to the other 4 bars, which we have a frequency of 40. So our total frequency we have here is 46.775. Out of the 50, we want it as a proportion, gives us 93.55%. We're told that it is claimed that the time to complete the puzzle is normally distributed. Comment on the validity of this claim. Well, first, if it's a normal distribution, we should have a vaguely symmetrical curve. Remembering a normal distribution has a bell-shaped curve that comes up and then drops down. So first, the reason we can see from the graph that it's roughly symmetrical. Not perfect, but roughly symmetrical. Secondly, the graph for a normal distribution should have 95% within 2 standard deviations. So we are looking at 95% of the distribution should be within 2 standard deviations. And we have approximately, as we can see here, 93.55%. So it's close. So when it's claimed that the time completed to the puzzle is normally distributed, that could be correct. Here we're told that 1,000 students at Cranbourne College. Out of those 1,400 study photography, 700 study business, and 200 study neither subject. And we're asked to use this information to complete the Venn diagram. So first off, we can identify the students, the 200 that are outside of the photography and the business. Okay, so that leaves us with 800 that are in this section. So the probability that a student studies photography or business will be equal to, or the number will be equal to 800 out of the 1,000. So using the addition rule, we can then find the probability that someone studies photography and business. And that will be the part here in the middle. To find that, we take the probability that they study photography, add the probability they study business, and subtract the probability that they study photography or business. So we're looking at numbers now, not probability. So we're just taking the probability, but it works in the same way as the addition rule. So for photography, we have 400. For business, we have 700. Add them together, subtract the students who study photography or business, 800, to find the overlap, which will be equal to 300. So here in the middle, we have 300. So if photography altogether is 700, subtract the 300, we have 400 in this category. Then here for business altogether, sorry, the other way around, that was for business. Let me put that in the right place. So for business, we have 700. Subtract the 300. So we have 400 students studying business. Photography only has 400. Subtract the 300. So we have 100 students here for photography. Now we're asked for actual probabilities, so we're going to need to write our answers as fractions. First, write down the probability that the student is studying photography but not business. So photography but not business, so that's a yes, but not business are all the students who are here in the yellow section. We cannot include the students in the middle because they study business. So we have 100 out of the 1,000 students. We're then asked the probability that the students study both business and photography. This is the same as this here, which is the part in the middle, which in this case is equal to 300 divided by 1,000. Two students are picked at random. Calculate the probability that both are studying photography. So here we have two students and they are both studying photography. So let's take the probability that they study photography. The first student we're going to pick out of 1,000, there will be 400 divided by the total number 1,000. Now we pick this student, so there are only 399 out of 999. So our total probability, here we can see by multiplying across, we have 0.159759759. So rounding there to 0.16. Find the probability that a student picked at random is studying photography given that he or she is studying business. So this is really important. First, we need to identify that if a student is studying business, they must be within this circle. So if they are studying business, they must be within this circle. Therefore, out of this circle, we are looking at our probability out of 700. The number that studied photography is the 300 out of the 700, which is equal to 3 over 7. Now you can also find that by using our formula that the probability that the student does photography given they have business, which is found by the probability that they do both, divided by the probability they study business. By applying that, you'll come out to the same answer of 3 out of 7.